Okay, now to phase diagrams. So far, we've been talking about phase changes, changes of state of matter, and we've been talking about this only with regards to temperature. However, there is another side to this, and that's the idea or the influence of pressure. And what we're going to use to look at these two different environmental factors and how they interact are graphs called phase diagrams. So before we go any further, let's define what a phase diagram is. A phase diagram is a graph, obviously, a graph of pressure versus temperature that shows conditions under which the phases of a substance exist. And we use these to learn about phases and phase changes as temperature changes and as pressure changes. So this literally just gives info about phases and phase changes. And that's exciting. That deserves an exclamation point. So phases and phase changes. So let's look in here and let's find the phases and the phase changes. So the phases, first of all, we have liquid here. We have vapor down here. Over here we have solid. So those are the phases. And it said that it also gives information about phase changes. Well, these lines here and here tell us about phase changes. As you go across this line, you're going from a vapor to a liquid. And as you go across this line this way, you're going from a liquid to a vapor. And if you go this way, you're going from liquid to solid and then solid to liquid. So these lines show us where the phase changes occur. Let's go ahead and label that. So if we go across the line this direction, we are vaporizing. If we go across the line this direction, we are condensing, the opposite of vaporizing. If we go across this line this direction, we're going from solid to liquid, which of course is melting. And if we go the opposite direction, we are freezing. Now notice that this particular phase diagram happens to be for water. But we can have phase diagrams for all different kinds of substances. Okay, like last class we talked about the idea of what would happen if you held up dry ice and it went from this solid chunk of dry ice, which is just frozen carbon dioxide, into a vapor. So that's going from solid to a vapor. That's called sublimation. And if we went the other direction, if this vapor, this gas, went straight to a solid form, that would be called deposition. And we said that on Earth, that doesn't happen very often, especially not with water, but it can occur. And we said that it can occur usually like on the top of mountains because the pressure up there is so low. Notice pressure's over here. The lower you go, it's possible to have vapor turning directly into a solid, or a solid turning directly into a vapor if the pressure's low enough and the temperature's low enough. Okay. So that's the general information about how to read this diagram. Okay. Now there's a couple things in here that we want to point out. And let's move down where it says things to notice. We're going to fill in this section next. Things to notice about this phase diagram. First of all, the boundary lines between the phases are where both phases exist in a state of equilibrium. And that means that along this line, if you were to pinpoint this point right here, or this point right here, water liquid and water vapor would be at equilibrium. They'd be like bouncing back and forth between the two. They can't decide which one to become. And down here, same thing, but with solid and vapor. They'd be bouncing back and forth. They wouldn't be able to decide which one they're going to become. So when we say this idea of normal boiling point and normal freezing point, that really means that these points change. And so far we've been talking about this at this like magical number, and we've said that this happens at standard pressure, which is 1 atm or 1 atmosphere. And so you'll notice that on the graph we have normal freezing point and normal boiling point, and they both occur over here at standard pressure. And you'll notice also that if you were to go down, this occurs at 0, so normal freezing point is 0 degrees centigrade, and down here normal boiling point is 100 degrees centigrade. However, if you increase the pressure of the system, that boiling point starts to creep up. If you were to decrease the pressure of the system, that boiling point starts to move down, until which point where you get such low temperature that boiling doesn't even happen, or liquid doesn't even happen. It just goes straight from solid to vapor. It's still called boiling, or it's still called you're still moving towards vapor, but it's not actually called boiling at that point. Now, down here, this is a very interesting place on this phase diagram. You'll notice it exists right here at 0.01 degrees Celsius, and it exists over here at 0.006 atmospheres. This is a place called the triple point. And this point is kind of interesting, and I'm going to show you a little video clip about this in just a second. This is the temperature and pressure where all three phases exist in equilibrium. That means that if you were at the triple point for water, you would have solid, liquid, and gaseous water all happening at the same time. And the only reason why that's possible is because they're kind of bouncing back and forth between those